In this lesson, we're going to be focusing on parametric differentiations. Now, if you're given two functions, say y is equals to t squared and x is equals to 2t, and notice that we have separate two dependent variables here and then one common independent variables. So how do we find dy dx? How do we find the derivative of this function y with respect to this function x? Now, that's where parametric differentiation comes in. First, to find dy dx, it is given by dy dt, which is the derivative of this first function y is equals to t squared, divided by the derivative of the second function x is equals to 2t, which is dx dt. Now, how do you know that this arrangement is correct? Let's simplify this. We have dy dt multiplied by, if you take the inverse of this, we're going to have dt dx. Alright, now this dt and this dt will cancel. We'll be left with dy dx, which is what we have here. So once we find dy dt and then dx dt, I'm just going to apply this operation we have here, and then we get our dy dx. Now notice that for this to work, your dx dt must not be equals to 0. Alright, because if it is 0, the whole function, the whole thing will be undefined. So let's start by finding dy dt. So you have that dy dt is equals to, we're going to differentiate this first function, which is y equals to t squared. And if you differentiate this t squared, we're going to have 2t. Alright, now let's differentiate x is equals to 2t with respect to t. Now dx dt is going to be equals to, if we differentiate 2t, we're going to have 2. So let's substitute dy dt and dx dt with 2t and 2 respectively. We're going to have dy dx is equals to, dy dt is 2t divided by dx dt is equals to 2. So this is equals to 2t multiplied by, we are going to take the inverse of these two, it's going to be 1 over 2. Now these two and these two will cancel. We're going to be left with t times 1 is equals to t. So we have that dy dx is equals to t. And so this is the answer to this question. Now what about dx dy? How do you find it? Well, it's just easy by simply taking the inverse of this t. So dx dy is going to be equals to 1 over t. Or if you want to use this method and find it, dx dy is going to be equals to dx dt divided by dy dt. Notice that here I have dy at the numerator, and then I started with dy, and then here I have dx at the numerator, and then I started with dx. So anytime you want to find dy dx, make sure you start with dy, and anytime you want to find dx dy, make sure you start with dx. Arrange it in that way so that you get the answer. Let's have another problem. We have y is equals to 1 minus cosine t, and x is equals to t minus sine t. We ask to find dy dx and also dx dy using the full formula. Now first, to find dy dx, we have that dy dx is equals to, we're going to differentiate this first function. By the way, I want you to pause this video and try this question out, know if you're going to get it. Then after trying, you unpause it and watch the solution. So we're going to have dy dt divided by dx dt. So let's find dy dt. Dy dt is equals to, now this one is a constant, it's going to be equals to 0. The derivative of any constant is 0. Then we have minus, if we differentiate cos t, we are going to get minus sine t. And so minus times minus is equals to plus, so this one will give us sine t. Now if we differentiate x with respect to t, we have that dx dt is equals to, if we differentiate t, we're going to get 1, then minus, if we differentiate sine t, we're going to get cosine t. So this is the two answers for the y dt and the x dt. Let's substitute them into this equation here. So we have that the y dx is equals to, the y dt is sine t, then divided by the x dt is 1 minus cosine t. We have 1 minus cosine t. So we have that the y dx is equals to sine t divided by, or rather multiplied by, we take the inverse of 1 minus cosine t. It's going to be 1 divided by 1 minus cosine t. So the final answer is the y dx is equals to sine t divided by 1 minus cosine t. And so this is the answer to this question. Now tell me, is this the answer you got when you tried solving it? Tell me in the comment section. Alright, now let's find the x, the y. Now to find the x, the y, this is going to be equals to the x dt divided by the y dt. Alright, now the x dt, which we have found earlier here, is equals to, oh no, I've wiped it out, but then the x dt is equals to 1 minus cosine t, then divided by the y dt is equals to sine t. So this is going to be equals to the x dt is equals to 1 minus cosine t, then multiplied by, let me put this in parentheses, multiplied by 1 divided by sine t. So the x dt is equals to 1 minus cosine t divided by sine t. As you can see, this is the inverse of this dy dx that we found earlier. You get? So let's go to another question. So if you have y is equals to sine t and then x is equals to cosine t. Now I want you to pause this video and find the x, the y. So you have that the x, the y is equals to the x dt divided by the y dt. Now let's find the x dt. We are going to differentiate x with respect to t. Now if we differentiate cosine t, we are going to get minus sine t. Then next is to find the y dt, and then if we differentiate sine t, you are going to get cosine t. So the x dy is equals to, the x dt is negative sine t, then divided by the y dt is cosine t. So have that the x dy is equals to minus sine t multiplied by 1 over cosine t, which is equals to minus sine t over cosine t. And then you know that sine t divided by cos t is the same thing as tan t. So this is the answer to this question. Now let's try this one more question. So this is the last question we're going to be solving, and I want you to pause this video and give it a try. We have x is equals to 2t cubed plus 1 and y is equals to t squared cosine t. I want you to pause this video and find the x dt, also find the y dt, and finally you find the y dx. Okay, now let's start with the x dt. We're going to differentiate this x with respect to t. Then if we differentiate 2t cubed, we're going to get 6t squared. we are using the power rule. 3 times 2 is 6, then times t. We remove 1 from 3. 3 minus 1 is equals to 2. Then 1 is a constant. The derivative is 0. So this is the x dt, and then this is this. We have found this. Then the second one is dy dt. Dy dt is equals to, now if you take a look at this y function, you see that we have two terms multiplying each other. T square is multiplying cosine t. We are going to differentiate this using product rule. Now, how do we do that? We are going to keep this t square constant and then differentiate this cosine t. Then plus we differentiate t square and then keep cosine t constant. So this is how it goes. We are going to keep t square constant. We have t square. Then if you differentiate cosine t, you're going to get minus sine t. Then plus, we're going to keep this cosine t constant. We have cosine t and then differentiate t square. If you differentiate t square, you're going to get 2t. So this is going to be equals to, let me just write this one first. It's going to be 2t cosine t. Then this minus here, we bring it out. Then minus t square sine t. And so this is answer for this one. Then finally we find dy dx. So dy dx is equals to dy dt divided by dx dt. Dy dt is equals to 2t cosine t minus t square sine t. So I have 2t cosine t minus t square sine t, then divided by the x dt is equals to 6t square. So this is equals to 2t cosine t minus t square sine t multiplied by 1 over 6t square. So we have that dy dx is equals to 2t cosine t minus t square sine t divided by 6t square. Now notice that we have t here and we have t here, so let's factor it out. We also have t at the denominator. So if you factor out t, we're going to have t into, you'll be left with 2 cosine t, then minus t squared divided by t is t, you'll be left with sine t, then divided by, if you bring out t here, you have 6t. T squared divided by 2 is t. Alright, so this and this will cancel. Then we have that dy dx is equals to 2 cosine t minus t sine t divided by 6t. And so this is the answer to this question. I hope you have learned all you need to know about parametric differentiation. Thank you for watching. Please remember to subscribe to my YouTube channel, like this video, share with your friends, and don't forget to drop your comments. Have a nice day.